Hello and welcome to the lecture series on railways, harbour, tunneling and airport for the subject code 18CV645, Module 1 Session 7, creep. In this session, we are going to discuss about definition of a creep, creep theories, effects of creep, prevention of creep and measurement of the creep, and lastly the references. Moving on to the definition, that is creep in a rail. So we can define a creep as a longitudinal movement of the rail with respect to the sleeper. It means how much the distance it is moved in the longitudinal direction of a rail when measured with respect to the sleeper. So it is called as a creep. Rail have a tendency which can gradually move in the direction of a dominant traffic. It means it may be in the up direction or a down direction. So wherever we are going to be having more and more traffic, so in that direction we are going to be expecting a dominant with respect to the creep has been concerned. So this is a definition of a creep. Then how do you going to identify the creep? So the creep can be occurred on the rail. So this can be noticed by a successive closing of an expansion joint or a space, so in the direction of the creep. It means suppose if it is going to be in the forward direction, that is in the up direction, so there will be a successive closure of the rail joint in that particular direction, and also the opening out of the point where creep is going to be starting. So that is an indication. So next identification is we can have a mark over the rail flanges or the web which is made by the spike head. So due to the scraping or otherwise the scratching as the rail is going to be sliding. So that is an indication. So how do you going to measure or identify the creep? So to understand the phenomena of a creep, we are going to be having three theories predominantly. First one is going to be called as a wave motion theory, second one is called as a percussion theory, and third one is called a drag theory. So these three theories will going to give an identification or how the creep is going to be developed in a rail with respect to the sleepers. Moving on to the first theory, that is called wave motion theory. So as the name itself indicates that, so the creep are going to be identified due to the wave motion which is set in the resilience of a track because of a repeated moving load. So as it causes deflection in the rail under the loading, so this causes a wave motion in a track system. So hence the name, it is called a wave motion theory. So according to this theory, the portion of rail which is immediately under the wheel will get slightly depressed, that is due to the wheel loading. It means so due to the wheel load, so where the point of application of a wheel load is there, so that is going to be depressed a bit with respect to the straight portion. So therefore the rail is generally going to be having a wavy formation. So that is the reason, because of application of the point load, we are going to have the depression. So with respect to the measured rail section, so it is going to be having a wave formation. So as the wheel of the train move forwards, these depressions will going to move with them, and previously depressed portion springs back to its original level. It means whenever we are going to remove the wheel load, or otherwise if the wheel is moved away from the measured point, so once again the track is going to be rebound back to its original level. So this wave motion is having a tendency to move the rail forward with the direction of the train. So this causes the wave motion in the track system. The ironing effect of the moving wheel on the wave formed in the rail causes the longitudinal movement. So this is, as I explained, it is in the direction of a traffic which is going to be resulting the creep in the rail. So this is about the wave formation. So according to this theory, wherever the load is going to be applied, so that is going to be having a depression, and when the load is going to be removed, so the track system rebound back to its original level. So entire track system forms a wavy formation, so according to this theory. So for better understanding, so we can have the figure here. So we can say this is a first rail and this is second rail. So both are going to be bridged by the fish plate and a fish board, which is been supported over the sleepers. So this is a direction of a wheel. So that is, if the first wheel is going to be exactly on the joint, and we can expect if the same point in the direction of a motion. So here exactly on the point of a wheel, so we can expect some amount of a depression, whereas the adjacent sides are going to be upward. So that is, this portion is upward, and exactly at this portion it is going to be having a downward, or it is going to be a loaded portion. Suppose if this wheel is going to be moved to the second point, so this is going to be rebound back to its original position. So that is on the dotted line. So it means it come back to its original level. So in the another image, so we can see that, so that is one indicates the wheel, second is the direction or the movement of a wheel. So next is going to be the trailing rail section, and this is going to be called as a facing rail section. This is the joint, and these are going to be the sleepers. So whenever we are going to be having according to this theory, if the point of contact on the rail is going to be forming a depression, and the adjacent sides are going to be having the wavy formation. So this is the phenomena of wave motion theory for the creep. So the wave action can be reduced by adopting a few of the measures, namely angular and heavy ballast. If you are going to be put around and also below the sleeper, it is going to be providing good interlocking property, hence the wave action can be reduced. Similarly, if you are going to be increase the stiffness of a track, so that is also going to reduce the wave action. Similarly, if you reduce the spacing between the two sleeper, so that is also going to be having reduces the wave action. Similarly, if you are going to have a bigger cross section of a rail, so that is also going to reduce this wave action. Moving on to the next theory, so that is called percussion theory. According to this theory, creep is going to be developed due to impact of a wheels at the rail end ahead of a joint. So here it is due to the impact. So there in the previous, that is a wave formation, it is going to be a contact of the wheel load. So as the wheel are going to be moving and the trains leave the trailing rail at the joint, the rails are going to be pushed forward, causing it in the longitudinal in the direction of the traffic. It means according to this theory, the impact of a wheel at the rail end pushes the subsequent rails, so in the longitudinal direction of the traffic. So though the impact of the wheel might be a nominal, but it is a continuous movement because of several wheels are going to be passing over in the joint. So this joint pushes the facing and landing rail forward, thereby it causes the creep. So for better understanding, we are going to be analyzing the percussion theory by using this concept. So here we are going to be say the left side is called as a trailing rail, and next rail is going to be called as a facing rail. So whenever we are going to be apply a wheel load near to the joint, so the trail rail is going to be behind that one, it pushes the facing rail in the forward direction, that is in the direction of a P. So thereby it is going to be resulting R force in the system. So this is according to the percussion theory. So according to the percussion theory, so creep by this theory will going to be increased due to the following factor. So this theory explains is going to be there might be a weak or a loose fish port. Suppose in a rail joint, if the fish ports are going to be loosened, so there might be a gap or the chances of moving in the longitudinal direction of the rail. Similarly, if fish plates are also going to be worn out, then there might be a chances of occurrence of a creep or otherwise if there is a loose packing at the joint. So, that is if the ballast is going to be loosely packed near to the or surrounding the joints. So, that is also accountable. Similarly, there is a wide expansion gap if you are going to be providing. So, that is also going to be accountable for the creep. Similarly, if heavy axial loads moving at a faster speed, then this is also going to be accountable for the creep has been concerned. So, this is according to the percussion theory. So, next theory, that is going to be the drag theory. According to this theory, the backward thrust of the driving wheel of a locomotive is having a tendency to push the rail in backward, while the thrust of the other wheel of a locomotive or the trailing wheel going to push in the direction of the locomotive where it is going to be moving. So, this is going to be resulting a longitudinal movement of the rail in the direction of a traffic. So, thereby it causes the creep. So, these are the three theories which are going to be used to analyze the creep. So, next we are going to have what exactly the causes for the creep. So, causes are many. So, we are going to discuss one by one. First is ironing effect of a wheel. So, ironing effect of a wheel is nothing but whenever we are going to be having a moving wheel on the waves, it is going to be formed from the rail. It is going to be tends to cause rail to move in the direction of a traffic. It is going to be causing or it is resulting in the form of creep. So, that is going to be called as ironing effect. Next is due to starting and stopping operation. So, whenever the train is going to be starts or accelerates, or it is going to be causing some amount of backward thrust to its wheel, and thereby it tends to push the rail in a backward. Similarly, when it is going to be slowing down or it coming to halt, so the same effect or it is going to be due to application of a brake tends to push the rail in the forward direction. So, the consequence of both the starting and stopping operation can have a tendency to develop a creep. So, that is once again in the direction of the traffic. Similarly, if there is a changes in the temperature is also going to be accountable. So, this is due to the temperature variation or linear expansion. It is going to be caused in the rail section or the contraction which is going to be occurring in the rail. So, this is also going to be a cause for the creep formation. This is going to be more frequent whenever we are going to be having hot weather condition. Next cause is going to be unbalanced traffic. Suppose in a double line section, if the trains are moving in a unit direction, hence the creep is going to be developed in the direction of a traffic only. Apart from this one, we are going to be having many more type causes. So, next is going to be alignment. Wherever we are going to be having a curves on a tangent, so it is going to be whenever we are going to be having a curves, so on the tangent of a railway track, so that is also going to be having a creep. So, next is a type of a rail. So, it is a new rail or it is a older rail. So, as compared to the older rail, it is going to be having a more creep as compared to the new ones. So, similarly grade of a track. So, whenever we are going to be having a steeper gradient, so whenever we are going to be having a heavy axial load, so which is moving at a downward gradient, so thereby it is pushing in a longitudinal direction in the predominant of the traffic. So, that is also going to be accountable. Similarly, the poor maintenance of a track, so that is going to be accountable for the creep, but some minor factors is also going to be there. So, they are improper securing of a rail to the sleeper, that is improper fixation by the fastening or the fixtures, limited quantity of a ballast, that is not providing a minimum quantity. So, improper expansion gap. So, next is badly maintained rail joint. So, next is rail seat wear, especially in case of metal sleeper, when rails are too light, that is weight of the rails are going to be lighter when compared to the traffic which is going to be carried, And next is the yielding formation, which is due to uneven cross levels, so that is also going to be accountable. Lack of drainage, loose packing and uneven spacing of a sleeper are also going to be accountable for the causes of creep. So these are starting from ironing effect to the poor maintenance practices of a track are going to be liable for the formation of creep. So we have studied what exactly the creep and the theories which are going to be explaining, and also the causes. We can set what could be the effect of a creep. So the effect of creep is going to be, it's going to be a slippering out of the square. So whenever it is going to be moving out from this position, as a result creep are going to be formed in square, which is lead to unpleasant ride. So it is going to be what we say, some amount of disturbance it is going to be caused over the rail section. It is going to be causing unpleasant ride. Similarly, expansion in gap, it is going to be getting disturbation. So that is going to be due to these places wherever we are going to be having a closure of a gap, or it is going to be going to induce undue stresses over the fish plate or a bolt. So that is going to be accountable, or it is going to be affecting the smooth working of a switches in expansion joint, or in case of a LWR, that is a long welded rails. Next is the distortion of a points and crossing. So whenever we are going to be having a excessive creep, it is very difficult to correct the gauge in the alignment, so especially at the points and crossing. So these are some of the ill effects of creep. So moving on to the some more ill effects. So or the effect, it is difficult to change in the rail. So that is in a maintenance point, if you are going to change for a new rail, it is going to be short or too long, it is going to be fixed over that one. Effect of interlocking mechanism is disturbed. Possibility of a buckling of a track. So once again the improper maintenance of a track is going to induce the excessiveness, which is going to be leading excessive creep is going to leading the buckling of a track. So some more effects are going to be the breaking of fish bolts or the kinks in the alignment. So that is going to be occurring at various situations. So these are going to be the ill effect of or the effect of creeps. So how are we going to measure the creep? So creep can be measured with the help of a device which is called as creep indicator. So the creep are going to be measured. So in between the two sleeper, say for example, so this is a first sleeper and this is a second sleeper. So when we are going to be a rail post which is having a creep indicator, or a string is been tied in a horizontal direction with a fixed, which is going to be for on the top of the sleeper, a fish string is going to be stretched below to the mark of to mark the creep with respect to the sleeper position, which is to be measured. The distance between the chisel mark and the string where it is being moved ahead with respect to the amount of the chisel mark is going to be measured as a creep. Say for example, we are going to be having a post here. Say this is a post where a string is going to be drawn at exactly the foot level. So where on this mark a chisel mark is going to be put where the initial string is going to be tied over. So after allowing of a traffic, so this sleeper or the rail is going to be moved ahead from its chisel marker. So this difference we are going to be measured. So that is a creep measurement. So how do you going to prevent the creep? So we had studied the causes and effect. So how are you going to prevent the creep? So the prevention of creep can be done in the following fashion. So first one is pulling back of a rail. So as we know that, so when the rail is going to be moved in the longitudinal direction, if we going to pull back to its original level by the inspection, so that is going to be giving by a proper joint by using a crowbar or a hook. So that is the first method, which is called as pulling back of rail. So as it is going to be a tedious process, it is possible only for the smaller length. Similarly, if you are going to be providing the anchors or anti-creepers, so say for example, if you are going to be providing a very good fixity for the rails and the sleeper, there is no adequate space to move the rails in the direction, so those are going to be called as the provisions of a anchor or anti-creeper. So these are going to be prevented by using a creep ballast. So for creep, if it is going to be from 75 to 150 mm in a month, then 4 anchors per rails are going to be provided, or for if the creep is going to be 225 mm to 250 mm, so 6 anchors per rail length is to be provided. So this is according to Indian practices. Similarly, if you use the steel sleeper, so as it is going to be a good grip over the ballast and the fitting, so some amount of creep can be prevented. So increase in a number of sleeper, that is also going to have a prevention over the creep. So these are some of the standard textbook we had referred to prepare this session. Similarly, the web references. Thank you.